Hello, my name is Kevin Moore. I am Director of Product Management for Live Transcoding at AWS Elemental. And I'm here to give you a quick demonstration of an exciting new technology that we've released for our customers. And that technology is called Quality-Defined Variable Bitrate Encoding. So what is Quality-Defined Variable Bitrate Encoding? Well, put simply, rather than using the old method of fixing the bitrate regardless of what's happening with the content and then delivering ladders of bit rates to mobile devices in the world, let's deliver ladders of bitrate content, but let's allow the bit rates to be defined by the quality rather than by a fixed bitrate. Why would we want to do this? Two reasons. Sometimes our video content requires that we spend a few more bits on that content in order to capture the quality of difficult scenes. But most importantly, we want to make sure that we're not overspending bits on simpler scenes where we could be sending fewer bits, charging our customers less money in terms of network bandwidth, saving storage costs, and saving on CDN costs. So quality-defined variable bitrate encoding allows us to help our customers save money and to deliver a better quality of experience to their customers. I'm going to show you a couple things here. First, I'm going to start and show you how easy it is to configure this rate control mode in our AWS Elemental Live encoder. Secondly, we'll look at some data from QVBR channels that have been running for a long period of time, and we'll look at what kind of savings can be achieved with this new technique. So, here on my screen, I've got the user interface for AWS Elemental Live, where we configure new transcoding channels. So for those of you that are familiar with AWS Elemental Live, you'll see this is very straightforward. I have configured an output group here supporting HLS output. I've defined 3 streams, which I've just named at a quality level. Quality level 9, quality level 7, and quality level 5, whereas in the past I might have put a fixed bit rate in here. Here I put in a fixed quality. And then down below where I configure my streams, you can see I've configured this system for 1080p video at 30 frames per second. And down in the rate control mode, I've selected our new option, QVBR. Again, that's quality defined variable bit rate. Now, there's only 2 parameters that you need to define when you use QVBR. The first one is, of course, the quality level. So as we talked about having a ladder of quality targets, we have created a 10-point scale where 9 represents about the highest level of quality you would want for a premium viewing application, such as a large HD TV at a close viewing range. Sort of 7 or 8 represents where we might want to be, say, for tablet viewing, and 6 represents, a high-quality phone, but a phone nonetheless, and quality levels below that are for even more sort of constrained, challenged viewing environments. So it's a simple 10-point scale that customers use to build their ABR ladders. But it's also important that we provide the ability to define a maximum bit rate. As you know, certain scenes in content are just so difficult that if we allowed a quality-defined system to run completely unconstrained, we might generate a bit rate for that small snippet of content that, say, a cellular network couldn't deliver, CDN would have a problem with, so on and so forth. So it's important that we define this sort of maximum governor level here, just in order to constrain the predictability of the system. So as you can see on the first encode in my ladder here, stream number 1, I've set these values for 10 megabits with a quality level of 9. In stream 2, I've dropped down to 720p. I'm still running at 30 frames per second. I've dropped maximum bitrate down to 6, and I've lowered quality level to 7. In stream 3, same rate control mode, I've now dropped the resolution once again, so now we're doing only 540 lines tall. That maximum bitrate is set to 4, and that quality level is set to 5. Now, I want to stress, although I I did sort of ladder down those maximum bit rates. It's absolutely not required. You can get all of the savings of the rate control mode just by laddering the quality level. That's really all that's needed to achieve the savings. And that's all there is to it. Those of you that are familiar with Elemental Live realize that the difference between QVBR and CBR is pretty simple. In CBR, we set 1 bit rate. In QVBR, we set a maximum bit rate and we set a quality level. And that's all the difference that there is. So what does this look like in actual practice? So what I have here is a demo application that we put together. It's running in a standard browser. It's running in my Chrome browser here. And I'm showing the same feed encoded simultaneously 2 different ways. So we are encoding in CBR mode, and we are also encoding in QVBR mode. And here we've set the quality target at 8 megabits. And I'm not exactly sure what we set the maximum bit rate to, but again, that doesn't really matter. And then the graph that I'm showing down below is effectively the bit rate delivered over time of the QVBR stream, which is in blue, versus the CBR stream, which is in pink here. So as you can see, at certain points in the content, there were substantial savings to be had. In fact, if you look right now, we're in that right now. KissCam does not have particularly difficult encoding properties. So as you can see, during that period, we're able to save a lot of bits encoding these heartwarming scenes here. So, so that's basically the comparison that I want to show there. Now, I will cut over. So as you can see, this channel has moved from the footage of the stadium sporting event to footage of a parade here. This is the 2018 Rose Parade. And so as you can see, we have sort of diverse types of content that are flowing through the system, which is how over a long period of time, we're able to see all of this variation. And seeing all of the variation is very important because it's really those periods of low encoding complexity where QVBR really steps in and delivers consistently high quality while saving a bunch of money. We can get a slightly different view of this by, again, looking at that same stream, but we can look back and see all the different types of content. So as you can see, when the graphic was coming in, when we were panning over a big crowd, we allocated plenty of bits. 6.45 megabits were allocated in that time range. But you can see when we got to the talking heads period here, where it was just a camera fixed on one person for the interview, the QVBR encoder was able to spend only 3.42 megabits versus the CBR encoder, which was spending almost twice as much at 6.43. So clearly there's substantial savings to be had during many different periods of content here. There's the KissCam footage again. You can see certain advertisements were spending less than 1/3 of what we would otherwise be spending in a CBR time period. So we're saving a lot. And in fact, if you look at the content over a 24-hour window, just on the highest quality output, we're still saving 33% versus the target. If we move those quality targets down just 1 notch, we're able to save 68. 2 notches down, we're able to save 76% of the delivered bandwidth. And that is a very serious savings that linearly adjusts your storage costs, it linearly adjusts your CDN costs, and in fact, it saves your customers money as well because they pay less for the bandwidth that they need to receive your content. As we have talked with our customers about this technology, they've been extremely excited about it. But one question keeps coming up, which is, what is the player support? And that's a reasonable question. Anytime somebody makes a significant change in sort of some of the baseline assumptions about our industry, it's reasonable to ask questions about the types of support that we're going to get. So, of course, as you can see right here, we have great in-browser support. We're running the hls.js player. That's having no problem at all with our QVBR streams, which are changing their segment sizes segment by segment. But most importantly, we're able to show that we have great support on mobile devices. And so in fact, over here on this camera, I'm showing this same content from these same URLs running on iOS 11. This is the stock iOS HLS player. And it's been streaming on my Q6, quality level 6 output, and it's been streaming like a champ, no problems whatsoever. So we're happy to report that not only can this technology save a lot of money, it doesn't sort of introduce any player compatibility issues. We think that this is a great technology for the market. We think it's going to help our customers save a bunch of money, and we're very excited to bring it. If you'd like to hear a little bit more about the theory behind QVBR, we recommend that you check out our session that's going on over in the main theater, and you can see a presentation that gets more into the theory of how these savings are achieved. All right, that's it. Thank you very much. I appreciate you watching our demo.